Assalamualaikum. My name is Amzara Sekhan bin Azamhan, and in this video I would like to demo my experiment. So let's start with the import library. So we use NumPy, Pandas, Seaborn, Matplotlib. Then we use import smooth, and we use train test split for spin dataset. Use normalization and scaling for the pre-processing. We use cross-val score for evaluating model performance. So at the model, we use the SVM for feature selection. We use to select k-best and chi-square, and then we use hyperparameter tuning with grid search. We start by selecting the dataset with this Google Colab import file. So next is for data preparation. This is our data frame. Next, we check the data types. So we check the numerical data. This is the table for it. Then you can see the categorical data. So then we store all the column name in a list. So this is the size of our data set. So then we check for null values. As we can see, there is 201 missing values in the BMI attribute. So to handle missing value, we replace the value with min. Then the missing value is gone. So there is no missing value anymore. This is to show the unique values for each attribute. For example, the gender is the male, female, other, and age. Then we move on to the data outlier to identify a data outlier. So we create a 2x2 grid subplot. This is for creating a plot for the data outliers. For the output, you can see the distribution of age, hypertension. This is to show the data outliers present in the dataset. We have detected data outliers, so we need to handle it. This is the code for data handling. We used to calculate the 25th and 75th, which is the quarter 1 and quarter 3 for the column. Then we calculate using the interquarter range, and we define the upper and lower bounds for detecting outliers. So in the end, we have fixed outliers. This is for the average glucose level. Outlier found is 627. In the BMI, we found that there are 126 rows of data outlier. So after we handle the data outliers, this is the result for the average glucose level and BMI. Next, we use one hot encoding to change the categorical data into numerical. For example, the gender, the married type, resident type, smoking status features are all category data. So we need to change to numerical data using one hot encoding. After that, the result of using one hot encoding can split into many sub features. For example, for the gender, it will split into two: gender male and gender female. So we can see the highest is stroke, the second highest is age, which is 0.25. Then we move on to the data imbalance handling. So this is the illustration for the distribution of stroke, which is almost over 5% of people that have stroke and 95% don't have stroke, which causes data imbalance. So after we use for the data imbalance, we use mode. So after using mode, the illustration looks like this. It's 50 and 50. After mode, for example, there is 9,720 for both, and before mode, total sample is 5,000. So the positive and negative sample are the same. Is the table. Next, we move on to data normalization or data scaling. So this is what it looks like before data scaling. And we use the min-max scaler for data scaling. Then we split data, and the result after scaling is this. So we move on to the next phase, which is the SVM, developing the SVM model. Before that, we need to split the data and train the data set into 80 and 20%. So first, we initialize the SVM classifier. SVM is SVC. Create the dictionary of all model with their respective abbreviation as keys. Then this is the function to train and evaluate model using cross-validation. And next is to select features. We use the select k-best and chi-square. So this code is to plot the accuracy score. So this is to calculate the mean accuracy from cross-validation. This is to create a data frame from cross-validation accuracy score. And this is to create a data frame of model accuracy using cross-validation. So our output will look like this, which is number of features used 0.885, which we use in the research. Next is the select k-best using chi-square test. This to list the feature names, the score, and the p-values, which is this. Then we move on to hyperparameter tuning. So this is our parameter, kernel type and kernel coefficient. So we train the SPM model that we developed using the parameter and hypertuning. So in the end, we get the best parameter. Using hypertuning, we get the best parameter, which is C equals 10, 0.9, and using kernel. So we use that for our evaluation. So we train the model, and the output, in the end, we get the accuracy score of 0.897634. So next step which is the model evaluation and conversion matrix. So in the conversion matrix, this is the result. Ultimately, we get the accuracy rounding off of 0.89 to 0.9. We get the precision of 0.89. We got the recall of 0.91, F1 score of 0.90. Okay, that's all for me. Thank you.